Antarctica, with its merciless climate and impenetrable ice, has kept its secrets buried deep, rendering any exploration a daunting, nearly impossible task. This veil of mystery has fueled tantalizing theories that humanity once called this frozen wasteland home. Among these is Graham Hancock's Antarctic civilization hypothesis, a daring and controversial theory that shakes the foundations of our understanding of history. Hancock suggests that an advanced civilization thrived in Antarctica thousands of years ago, long before the rise of Egypt or Sumeria. There's undoubtedly a time they found fossils on Antarctica. There's undoubtedly a time when Antarctica was, which is my first book tracing the possibility of a lost civilization. Sadly, this civilization was wiped out at the end of the last ice age due to 3 massive floods that happened between 12,800 years ago and 11,000 years ago, likely by a comet. Seriously proposing that the Earth was hit by multiple fragments of a giant comet 12,800 years ago, and that this caused a huge rise in sea level and extinctions of megafauna, they are not saying that it also wiped out a lost advanced civilization of prehistory. One of the cornerstones of Hancock's hypothesis is the Piri Reis map, a world map created by the Ottoman admiral and cartographer Piri Reis in 1513. This map has intrigued historians and researchers for decades because it appears to depict the coastline of Antarctica long before the continent was officially discovered in 1820. Even more intriguingly, some interpretations suggest that the map shows an ice-free coastline, which would be a geological impossibility under the current understanding of Earth's climatic history. Hancock and other proponents of this theory argue that the Piri Reis map could be evidence of ancient knowledge of Antarctica, possibly passed down from a highly advanced but forgotten civilization. According to this theory, such a civilization might have existed during a period when Antarctica was not covered by ice, possibly during the last interglacial period over 100,000 years ago or even earlier. This civilization could have mapped the continent and preserved this knowledge, which eventually made its way into the Piri Reis map through a series of ancient cartographic traditions. Another key element of Hancock's theory is the notion that Antarctica could have been ice-free and habitable in the distant past. To understand this dramatic transformation, we need to delve into the geological and climatic history of the planet. Antarctica's journey from a temperate, ice-free continent to the frozen land we know today is a story of continental drift, climate change, and the shifting balance. Antarctica was once part of a supercontinent called Gondwana, which existed around 600 million years ago. Gondwana included present-day South America, Africa, India, Australia, and Antarctica. During this time, Antarctica was located much closer to the equator, and the climate was warm and humid. The continent was covered in dense forests with rivers and lakes, supporting a diverse array of plant and animal life. Fossil evidence from this period reveals that Antarctica was home to a wide variety of flora and fauna. The fossilized remains of ferns, conifers, and other plant species have been found in various locations across the continent, indicating that it was once covered in lush forests. These forests were similar to those found in present-day New Zealand or southern South America. The discovery of dinosaur fossils in Antarctica also suggests that large reptiles roamed the continent during this time. Over millions of years, the continents began to drift apart due to the movement of tectonic plates. Antarctica gradually moved southward, away from the equator, and toward its current position at the southernmost point of the Earth. As the continent moved closer to the South Pole, the climate began to change. The warm, temperate conditions that had allowed forests to flourish began to give way to cooler, more arid conditions. The breakup of Gondwana played a significant role in this transformation. As Antarctica separated from the other land masses, ocean currents began to flow around the continent, isolating it from the warmer waters to the north. This led to the development of the Antarctic Circumpolar Current, a powerful ocean current that flows from west to east around Antarctica. This current acts as a barrier, preventing warm ocean waters from reaching the continent and contributing to its cooling. As Antarctica continued to drift southward, the cooling trend accelerated. The continent's position at the South Pole meant that it received less direct sunlight, particularly during the winter months. The long, dark Antarctic winters and the reduced amount of solar radiation reaching the surface caused temperatures to drop even further. Over time, the forests that once covered Antarctica began to die off, replaced by tundra and eventually by vast ice sheets. The formation of the Antarctic ice sheets was a gradual process that took place over millions of years. The first significant glaciation events began around 34 million years ago during the Eocene-Oligocene transition. This period marked a significant drop in global temperatures, leading to the formation of ice at the poles. The cooling was driven by a combination of factors, including changes in Earth's orbit, reductions in atmospheric carbon dioxide levels, and the continued isolation of Antarctica by ocean currents. As the planet cooled, snow and ice began to accumulate on the continent, forming glacier. These glacier grew over time, eventually merging to form the vast ice sheets that now cover Antarctica. The growth of the Antarctic ice sheets had profound effects on global climate and sea levels. As more water was locked up in ice, sea levels dropped, exposing continental shelves and altering ocean currents. The increased albedo, or reflectivity, of the ice sheets also contributed to further cooling, creating a positive feedback loop that reinforced the glaciation process. Despite the harsh conditions, life persisted in Antarctica, adapting to the changing environment. Marine life in the surrounding Southern Ocean continued to thrive, with species such as krill, fish, and penguins evolving to survive in the cold waters. However, on land, the once diverse ecosystems were largely wiped out as the ice sheets advanced. Some remnants of Antarctica's ancient ecosystems can still be found today. Fossil evidence, including well-preserved plant and animal remains, provides a window into the continent's past. In recent years, scientists have even discovered ancient microbes preserved in the ice, offering insights into how life can survive in extreme conditions. Research into these ancient ecosystems is ongoing, with scientists studying the genetic material of fossilized plants and animals to better understand how they adapted to changing climates. This research not only sheds light on Antarctica's past but also provides valuable information about how ecosystems might respond to future climate change. Things got dramatic as in the relentless pursuit of knowledge, the frozen veil of Antarctica has begun to lift, revealing secrets buried for eons. This land of everlasting mystery, as Admiral Byrd so aptly named it, is now the stage for some of the most astonishing discoveries of our time. Hidden beneath the icy expanse of the world's fifth-largest continent, vast enough to rival the size of the United States, lies the key to Earth's ancient past, its present enigmas, and the ominous clue to its future. Google Earth has unveiled what some dare to describe as the most intriguing enigma of all: two enormous openings at the continent's surface, gaping like dark eyes into the unknown. These portals are said to lead to underground tunnels and subglacial rivers, where the temperature hovers at a balmy 15 to 21 degrees Celsius, a stark contrast to the frozen wasteland above. But the mystery deepens. Could these subterranean realms be natural formations, or do they bear the unmistakable mark of human intervention? Perhaps these caverns and tunnels are remnants of a long-forgotten civilization, secret military installations, or, most fantastically, bases for extraterrestrial beings. In 2012, the mystery only thickened. Google Earth captured yet another anomaly, a colossal structure 14.5 miles long and 4.5 miles wide, buried beneath the ice. Was it a titanic UFO concealed for centuries or a clandestine research facility camouflaged to blend into its icy surroundings? Russian UFO researcher Valentin Dev added fuel to this fiery speculation in 2015 when he uncovered yet another bizarre image, a formation resembling four tanks lined up in military precision, facing what could be a crashed UFO, 204 feet wide and 40 feet tall. As if this weren't enough, 2016 brought forth a revelation that sent shockwaves through the scientific community, a pyramid-like structure emerging from the melting ice. Its four sides, eerily symmetrical, mirrored the ancient pyramids of Egypt, yet it dwarfed them, with one side stretching 2 kilometers across. The Great Pyramid of Giza, by comparison, is a mere 750 feet, or 220 meters, in height. Could this be evidence of a lost civilization, one that crafted colossal pyramids in the unlikeliest of places, hidden beneath Antarctica's ice for millennia? If so, how many more of these ancient structures lie entombed, waiting to be discovered? And if we entertain this theory for just a moment, if we dare to believe, questions flood the mind: who were these people? How did they accomplish such feats in a land so harsh, so inhospitable? Yes, ice core drilling has confirmed that millions of years ago this place was frozen solid, life impossible in such conditions. But in 2017, a team of German geologists uncovered something extraordinary. Their drills, piercing through thousands of feet of snow and ice, brought forth samples of ancient herbs and trees, flora akin to those found in lush rainforests. The implications are staggering. These samples suggest that during the last ice age, around 11,000 years ago, parts of Antarctica were not blanketed in ice but were teeming with life, forests standing tall where now only glacier reign. So we are left to ponder, could this pyramid-like structure truly be the work of an ancient civilization? Could there be more hidden beneath Antarctica's icy facade? The answers remain elusive, but one thing is certain: Antarctica is no longer just the frozen desolate continent we once thought. It is a place where our understanding of history, of human capability, and perhaps of life beyond our planet may be forever altered. However, note that Graham Hancock's theory that Antarctica, now a frozen wasteland, might once have been ice-free and possibly even habitable by an advanced civilization is an intriguing but highly speculative idea. It draws on a combination of historical cartography, geological speculation, and interpretations of ancient myths. However, the theory is not supported by mainstream science, which emphasizes the lack of direct evidence and the speculative nature of the claims. Regardless, these alternative narratives spark curiosity about the hidden chapters of our collective history. We find ourselves questioning the limits of human achievements and the existence of advanced civilizations that might have flourished thousands of years before our conventional timeline suggests. The pursuit of these alternative narratives reminds us that the survival of humanity has always been a precarious balance between our advancements and the threats that loom over us both from within and outside. While our species has made remarkable progress in science, technology, and societal organization, we remain vulnerable to a range of existential threats. Some of these dangers are natural, while others are the products of our own actions. Here are a few ways in which humanity could be severely endangered or even wiped out, highlighting the fragility of our existence on this planet. 1. Nuclear catastrophe. Nuclear weapons are perhaps the most immediate and terrifying threat to human survival. The sheer destructive power of these weapons, as demonstrated in Hiroshima and Nagasaki, poses a grave danger not just to the countries involved in a potential nuclear conflict, but to the entire planet. A full-scale nuclear war would not only obliterate entire cities and kill millions of people instantly, but it would also lead to long-term environmental consequences that could jeopardize human survival. The concept of nuclear winter, where the ash and soot from nuclear explosions could block sunlight for months or even years, is one of the most discussed scenarios. This would result in a dramatic drop in global temperatures, leading to crop failures, food shortages, and widespread famine. The radiation from nuclear fallout would contaminate water supplies and make large swaths of land uninhabitable. The global economy would collapse and societal order would break down as nations scramble to secure dwindling resources. Moreover, the threat of accidental nuclear war, where miscommunication or technical failures lead to the unintended launch of nuclear weapons, cannot be ignored. The proliferation of nuclear weapons to unstable regimes and the potential for non-state actors to acquire nuclear materials add layers of complexity and risk in a world where the destructive capacity of a single weapon could wipe out millions. The continued existence of nuclear arsenals poses a significant existential threat to humanity. 2. Climate change and environmental collapse. Climate change is a slow-moving but potentially devastating threat to human civilization. The scientific consensus is clear: human activities, primarily the burning of fossil fuels, are driving a rapid increase in global temperatures. The consequences of unchecked climate change could be catastrophic, leading to widespread environmental collapse, economic instability, and geopolitical conflict. Rising temperatures are expected to cause more frequent and severe weather events such as hurricanes, droughts, and floods. Sea levels are rising due to the melting of polar ice caps and the thermal expansion of seawater, threatening to inundate coastal cities and displace hundreds of millions of people. This could lead to mass migrations and conflicts over resources as people flee increasingly uninhabitable areas. The loss of biodiversity is another critical concern as ecosystems collapse. The services they provide, such as pollination, water purification, and climate regulation, could be severely disrupted. This could lead to food shortages, the spread of diseases, and the destabilization of global supply chains. The collapse of fisheries, the destruction of coral reefs, and the loss of arable land are just a few examples of how environmental degradation could directly threaten human survival. In the worst-case scenario, climate change could trigger feedback loops that accelerate warming, such as the release of methane from thawing permafrost. This could push the Earth into a hothouse state where large parts of the planet become uninhabitable, leading to the collapse of human civilization as we know it. 3. A supervolcano. Humanity has danced perilously close to the edge of oblivion before genetic whispers from our Distant past reveal a time when our numbers dwindled to a mere flicker of breath away from extinction. Many believed that this near-death experience was ignited by the cataclysmic fury of the Toba supervolcano erupting with a force so monstrous it blotted out the sun and poisoned the skies some 70,000 to 75,000 years ago. Though the exact cause remains shrouded in mystery, one truth looms large: supervolcanoes have the power to bring even the mightiest species to their knees. These geological behemoths unleash torrents of toxic gases, suffocating the atmosphere and plunging the planet into a deadly chill. The sun, once a source of life, becomes a distant memory as the sky fills with light-deflecting compounds, dooming the world to an icy, suffocating twilight. Supervolcanic eruptions are rare. The geological record tells us returning every 10 to 100 million years. But when they strike with a vengeance, leaving mass extinctions in their wake. And now the question haunts us: would such an eruption spell our doom today? The answer is cloaked in uncertainty. Our climate, already teetering on the brink due to our own reckless actions, would be pushed over the edge by a supervolcano. Death would sweep across the globe, and yet we are not the same fragile species we once were. Humanity has spread its roots far and wide, adapting to diverse climates, preparing for catastrophes that could obliterate our food supply and darken our skies. But modernity, with all its marvels, has also woven a web of vulnerability. Our food, energy, and communication systems are now global, interconnected, and frighteningly fragile. A single shock could send ripples of chaos across the world, cascading failures that would cripple our civilization. In other words, the dense interconnection of our systems has only increased the probability of a global collapse. So are we safer from extinction than our ancestors? Perhaps, but as we stand on the precipice staring into the abyss of a supervolcano's wrath, the only certainty is that we must prepare. We must strengthen our defenses, safeguard our food supply, and brace ourselves for the apocalypse that could one day come from the very depths of the earth. For artificial intelligence and autonomous weapons, the rapid development of artificial intelligence, also known as AI, presents both incredible opportunities and significant risks. As AI systems become more advanced, there is a growing concern that they could be used in ways that pose existential threats to humanity. One of the most concerning scenarios involves the development of autonomous weapons or killer robots that can select and engage targets without human intervention. If such weapons were deployed on a large scale, the potential for unintended escalation and loss of control could lead to widespread devastation. An arms race in autonomous weapons could destabilize global security, leading to conflicts that spiral out of control. The broader risks of AI also include the possibility of creating an artificial general intelligence, or AGI, that surpasses human intelligence. If such an AGI were to be developed without appropriate safeguards, it could act in ways that are detrimental to humanity. The classic paperclip maximizer scenario, where an AI tasked with producing paper clips optimizes its goal to the point of consuming all resources on Earth, is a thought experiment that highlights the potential dangers of misaligned AI goals. Moreover, AI could exacerbate existing societal inequalities and create new forms of oppression. The misuse of AI for mass surveillance, social manipulation, and cyber warfare could lead to the erosion of individual freedoms and the destabilization of democratic institutions. In a worst-case scenario, AI could become a tool of authoritarian control, leading to a dystopian future where human rights are severely curtailed. 5. Asteroid impact. An asteroid impact is a rare but potentially catastrophic event that could lead to the extinction of humanity. The dinosaurs' extinction around 66 million years ago is widely believed to have been caused by a massive asteroid impact which resulted in widespread fires, a nuclear winter effect, and the collapse of ecosystems. While the likelihood of a large asteroid colliding with Earth in the near future is low, the consequences of such an event would be devastating. Depending on the size of the asteroid, an impact could result in the release of energy equivalent to billions of tons of TNT, creating shock waves, tsunamis, and massive wildfires. The dust and debris thrown into the atmosphere would block sunlight, leading to a dramatic cooling of the planet and the collapse of food chains. The global community has made some progress in tracking near-Earth objects, or NEOs, and developing potential mitigation strategies, such as deflecting an asteroid with a spacecraft. However, our current capabilities are limited, and a large enough asteroid could still catch us by surprise. In the worst-case scenario, an asteroid impact could cause a massive extinction event, wiping out humanity along with most other life on Earth. 6. The end of the sun. The sun, our life-giver, is not the tranquil beacon it appears to be. Beneath its fiery surface, chaos reigns. Colossal magnetic fields spawn sunspots, monstrous storms, some dwarfing our entire planet. It hurls torrents of particles and radiation, an unstoppable solar wind towards us. When Earth's magnetic shield holds, we witness the breathtaking auroras. But should the wind rage stronger, it shatters our fragile communications, plunges cities into darkness, and severs us from the lifelines of power. The most terrifying storm on record. The Carrington event of 1859 wrought havoc on the primitive electronics of its day. Imagine now in our world where every breath is tethered to technology the cataclysm such a storm would unleash. No light, no heat, no air conditioning, no GPS, no internet. Food and medicine would rot and society would be on its knees begging for reprieve. And then there is the sun's ultimate betrayal, a ticking time bomb with a timer set for 7.72 billion years. It will swell, casting off its outer layers in a final cosmic death rattle, leaving behind only a ghostly white dwarf. But humanity will not bear witness to this spectacle. Long before this endgame, the sun will expand into a red giant, devouring Mercury and Venus in its apocalyptic hunger. For a moment Earth might seem to escape this cosmic annihilation, but the sun will unleash a solar wind so ferocious that it will drag our world into its fiery embrace. In 7.59 billion years Earth will spiral inexorably into the sun's burning death throes, consumed in a cataclysmic inferno, reduced to molten memories, lost forever in the void. 7. Biological warfare and pandemics. Biological weapons and the emergence of new pandemics also pose significant threats to human survival. The use of genetically engineered viruses or bacteria in warfare could lead to uncontrollable outbreaks that spread rapidly across the globe. The potential for bioterrorism, where non-state actors develop and release deadly pathogens, is a growing concern. Additionally, natural pandemics, such as the COVID-19 pandemic, demonstrate how vulnerable humanity is to the rapid spread of infectious diseases. While COVID-19 had a relatively low mortality rate, future pandemics caused by more lethal pathogens could have far more devastating effects. The development of vaccines and treatments may not keep pace with the spread of a new disease, leading to widespread casualties and societal breakdown. Moreover, the rise of antibiotic-resistant bacteria is an alarming trend that could render many of our current medical treatments ineffective, leading to a future where even minor infections could be deadly. Biological threats, whether man-made or natural, could cause widespread death and suffering, with the potential to wipe out large portions of the human population. Conclusion: the end of humanity as a species is not guaranteed, but we face a range of threats that could potentially lead to our extinction, from nuclear war to climate change to AI and pandemics. The challenges we face are complex and multifaceted. Addressing these existential risks requires global cooperation, investment in scientific research, and a commitment to preserving the planet for future generations. While we cannot predict the future with certainty, we must remain vigilant and proactive in safeguarding our continued existence on this fragile planet as we move forward.